So now what happens, the question is, what happens if we are dealing with an entry region? So it is easy to calculate a fully developed region. We just saw it reaches a constant value depending on constant surface temperature or constant heat flux. But what happens in the entrance region? So the entrance region is calculated using this graph. This graph is basically telling us how the Nusselt number is changing with the Reynolds number. In this case, for the entrance region, we need to use the number is called Garris number. It is product of the Prandtl number and Reynolds number over d over x. Okay. So what you do is, if you first in your analysis, you calculate x entry, and if the pipe length is shorter than x entry, then you calculate the Garris number. After you have the Garris number, depending on constant heat flux or constant surface temperature, you get the Nusselt number. And this is local. In this graph, we have the local values. So again, as you can imagine, so there are also situations we talk about hydrodynamic entry and thermal entry. So thermal entry means the flow is fully developed. So flow is fully developed, but the heat transfer is not fully developed. Okay? So in this case, so you can also have Prandtl number greater than 1. Combined entry means neither the hydrodynamic nor temperature boundary layers are developed. You cannot have a situation where you have the thermally developed situation but hydrodynamically undeveloped situation, because as we mentioned, the flow is always controlling the heat transfer processes. You can never reach a developed temperature profile if the flow is not reached the developed stage. And if you need to calculate an average Nusselt number for the entry region, so we still use the Garris number. The definition is also given in here. So we have this empirical equation. So this equation is valid when you have thermal entry or combined entry when the Prandtl number is greater than 1. So we have more complicated equation which gives a little higher range, which is when the Prandtl number is greater than 1. Alternatively, you can just read it from this graph. You calculate the Garris number, take the inverse of that, and read the Nusselt number.